All right, we're number 9. And number 9 said let Q be a real number. Suppose there's 3 distinct positive integers, a, b, and c, such that q plus a, q plus b, q plus 3 is a geometric progression. Show that q is rational. So what I want to do is go to the whiteboard and kind of parse the language again. And the problem with this is over here that there might be a lot of things said that I don't understand at this point. Now, what do I know? This is number 9. I know Q is a real number. That's been given to me, right? Suppose there are 3 distinct positive integers. Yep, A, B, and C are positive integers. I'll write that down for you. So there's 3 distinct positive integers. They're A, B, and C, such that Q plus A, Q plus B, and Q plus C is a geometric progression. And let me remind you about geometric progression is going to be. You'd have some initial term, I'm going to say A. The next term would be A times some common ratio R, where R is a common ratio, by the way. And the next term would be A times R squared, because you just multiply by R each time. So if that's true, maybe I shouldn't use A. That doesn't matter. I can use A. You can use a different one if you want to. But I'm going to say there's something in relationship about the terms, right? And I'm going to say I got the geometric progression, but what's the relationship about the terms? And there's a couple ones you want to take note of. One is something about common ratios. You could divide the terms and get the ratio R. But I'm starting to notice that the first 2 terms, when multiplied together, let me see if that's, let me take a look at this thing. No, I can't do that. I'm not gonna divide or do that multiplication over here. But I want to look at the. Let me just get this thing cleaned up a little bit. A, AR, and I'm going to say, the product of these 2 terms, which would be A squared times R squared, is related to this one over here. All right. So what's the relationship over there, though? It looks like just the product of the first term and the last term would be the square of the middle term. So I'm going to write that down then. So I'm going to write down Q plus A times Q plus C would equal the middle term squared. So I'm going to put down Q plus B squared. All right, let's see if we can handle that and see what happens over here. So I get Q squared plus, I'm going to say A plus C times Q plus AC. What do you get on the other side? You get Q squared plus 2QB plus B squared. Well, something nice happened here. I'll tell you what happened. These Q's are disappearing. Now, as soon as I don't remember what the question is, they want me to show that Q is rational. So I need to solve this equation for Q. And I need to show it's a ratio of integers. Let's see if we can do that. I'll write this over here. So an A plus C times Q minus 2QB, I'm taking this term, I subtract that from it, equals B squared minus AC. I'm going to factor a Q out. And what are you left off with? A plus C minus 2B equals B squared minus AC. So what do you get over here? Q equals B squared minus AC. Again, I want to remind you that A, B, and C are integers, right? They're positive integers, by the way, and they're unique. They're not the same. What do you get in the bottom? A plus C minus 2B. What did I show? It's a ratio of integers. All right, let me just take a look at that again. and just give it another little thought about it. Yeah, so Q is rational. I get a ratio of integers over here. All right, ratio of integers. Q is rational. And that's it. Thank you.